What is the GD&T stackup analysis?
GD&T stackup analysis. Anyone can answer? Yes, Rahul, Sachin, Raja,
Sir, what can you repeat?
Pranali.
What is GD&T stackup analysis?
What is GD&T stackup analysis? What is stackup analysis in GD&T?
Sir, GD and T are the manufacturing tolerance within which we have to manufacture the part.
Okay,
And stack up is a combined result of GD and T tolerances which we combinedly study.
awesome, awesome, perfect. Getting Sachin, Raja, Pranali, others.
Yes, sir.
Pranali, got the answer or shall I
Repeat.
explain? Okay, Rahul, could you please
Explain.
repeat? Please explain in detail, okay? Little bit. Rahul. Hello, Rahul, are you there?
Yes, sir.
Yeah, could you please repeat?
Sir, GD&T only mostly for rather than dimensioning tolerances, it is for geometrical tolerances, in which we covered eight types of GD&T. I think eight types, like circularity, concentricity, flatness, uh,
Okay,
profile of a surface, profile of a line. I think.
uh,
In which we measure the variation in flatness like that, not exactly flat, in which tolerance each of GD&T have separate definition. Like in flatness, we measure flatness of that surface in 3D,
okay,
about which mean line that flatness vary.
okay,
Uh, for example, flatness point 2, that means that surface will vary within point 2 about mean line.
okay. Now, what about the stack up? What is stack up?
Stack up, sir, we generally use stack up in assembly for in mating parts or fitment, or some propagated tolerancing, like in single part, if we dimension, uh, what we can say, we can dimension first dimension and rather it chained up further accordingly. On the total length we have to cover that dimensioning. That means we, in a part of length, we give some dimension of point 0.2, other of point 0.2, and then in total length of dimension tolerance, we can we have to give less than zero point 0.4 or up to zero point 0.5, I think.
Okay, good. Okay, so shall I explain? Yes, Sachin, do you want to add any points? Raja, others? What is tolerance stack up? Anyone wants to add any point? Okay, no issue. Let me share my screen. So, what is stack up? Everyone knows tolerance, yes or no? Tolerance means what? GD&T, the freedom for the design, for the fitment, we call it as tolerance. Yes or no?
Yes.
Okay, so simple example. Okay, see, this is a part. And this is the second part.
Yes, sir.
Okay, so this is the second part. Okay. Now imagine there is one locator over here. This is the locator, okay? And this is the second locator. Suppose there is two locators. There will be window in yellow part, yes or no? If you see from the top side, there will be window. Agree, yes or no? This will be the window. Yes, everyone. So suppose this is window, okay? Let's project this window over here, okay? The top view or the bottom view, it will be something like this. Agree, everyone? Yes. And this is the axis, or let's say, you already know every time we design the locator on a point. This point, yes or no? This point and this point. The window resting point, yes or no? Agree?
Yes, sir.
Now suppose this is your master axis system. Master means with help of this axis system, you are defining the position of the red part in yellow. Okay. Now you are define for the yellow part, you are define from this wall till this wall. The dimension is something, let's say x, or dimension is x plus minus 0.2. Okay, Pranali, plus minus 0.2 means
Yes, sir.
plus minus, let's say 0.2. Clear? Now for the red part, let's use green color. For the red part, you have defined this dimension 1. This will be the second dimension. This will be the third dimension, and this will be the fourth dimension, and this will be the fifth dimension. Okay, these are the dimensions in red part. Okay, now here you can see in yellow part you have defined this dimension till the window wall. Agree, yes or no? Please focus. In yellow part you have defined this x plus minus 0.2. This is the dimension between this wall and this wall of the window. Agree?
Yes, sir.
And suppose this is your yellow part. And from this side you have defined from this wall till this wall you are defining this one. Now this is your window size. Again from this to this will be your window size. Okay. Now tell me, I want this position. The position of this access system of the second locator. Please focus. This is our first locator. Where should I rename? This is first. This is second. Okay. Now this is, let's say this is 5 plus minus 0.1. Let's say this window is, the width is 2, again plus minus 0.1 for the window size. Now this is something x plus, okay, instead of x let's use a value. Let's take this a dimension as 20 plus minus something. Again, this dimension is 2 point something. 2 plus minus 0.1 again. Agree. Now for the green one, means for the red part, let's use red color. This dimension is something 3 plus minus 0.1. This dimension is I don't know, means let's say 4 16. Okay, 4 plus minus 0.1. Now this will be this dimension is 16 plus minus 0.2, and this dimension again 4 plus minus 0.1. Okay, and consider this as same dimension 3 plus minus 0.1. Clear? Any doubt?
No, sir.
Any doubt till this dimensioning?
No, sir.
No. Okay, now let's make a sum. Tell me, suppose this is y. This, let's draw axis system in yellow color. 1, 2, and normal to screen. This is z for me, this is y for me, and this x. Okay, so the topic is, the question is, so what is tolerance stackup? Stackup means summing. We will sum in a defined direction. Means suppose I want to sum up all tolerance and dimensions in y, and I want to check whether our red part will assemble in yellow part. Will it be okay or not okay? The position of this locator is okay or not okay? This is my first locator. Means this will be the master, what we can say, the fixation to locate the red part inside yellow part. Okay. So tell me, Pranali, what is this first dimension? 3
Plus minus 0.1.
Okay. So what will be the maximum and minimum dimension?
3.1 and 2.09.
2.9
9.
and 3.1.
1.
Same for this 4.1 and 3.9. For this
14.2 and 18.2.
15, 16.2 and 15.8. Yes. Yeah, Pranali, is it okay? Everyone? Nitesh, Sachin?
Yes, sir.
Okay.
Yes, sir.
So let's calculate this dimension. I want this one. See, I want this dimension. I'm using black line. I want this much dimension. This till this one. Tell me the total dimension. What will be the total dimension? Total maximum and total minimum.
So 20.03 is maximum and 19.7 is minimum, sir.
7.
20.7 is minimum, sir.
How you
Sorry,
calculate?
19.7 is minimum and 20.3 is maximum, sir.
Okay, you are calculating from this.
For center, sir. For center to first.
No, I want this dimension in red part.
Oh, okay, sir.
Yeah. Sachin?
24.4.
Okay,
20.4 is maximum.
let me note it down. So in red part, the maximum dimension is 24.4
4, sir.
4.
and minimum
23.6.
23.6. This will be min. Okay. Now tell me the same dimension in Yellow part.
$24.4, sir. Maximum.
Just a minute. Let me edit this dimension. Instead of 20, make it 22. Okay. Sorry. Yes. Now tell me the total dimension in yellow part.
So 24.4 is maximum.
4.
Yes,
Yes, sir.
yes, sir.
How you calculate the 4?
Sir, for center, 2 is divided by 1, by 2, by 1, sir.
26.04. Sorry, 26.4 is maximum.
So
No.
the
Sachin,
Windows
please.
total length is 2, sir, but we will calculate it in center, sir. So by 2.
So I want this distance.
Yes, sir. 1, sir.
So this will be the 1 on this side.
Yes,
On
sir.
another side will be 1. So it will be 24. Agree?
Yes, sir.
Yes, sir.
24. Now point. This is plus 0.2. Okay. For now, let's assume on this side the tolerance will be 0.5. Yes or no?
Yes, sir.
Yes, sir.
And same for this side 0.5. So what will the total?
24.3.
24.3.
Okay, this will the max and min. Sorry, this will the max and min.
23.7.
Okay. Now tell me, this is the max dimension and this is the min dimension. What is the use of tolerance? Why we are providing tolerance? The main benefit of tolerance. See, a small example. This is the cylinder and there is one hole. I want to insert this cylinder in this hole. What is the dimension of hole? Let's consider. The diameter of hole is let's say 5 plus minus zero point 0.2. What should be the diameter of cylinder? Tell me for good assembly. Diameter of cylinder, sorry. What should be the diameter of cylinder? What is our intention? It should go through that hole. Let's take, we don't want to assemble. Okay, let's take the assemble. If we move this cylinder, black cylinder inside this white part, we are going to weld. We will apply welding. So welding will be on this corner. Now tell me what should be the diameter of. So the cylinder will be something like this after assembly. Okay. So tell me what should be the diameter of red cylinder now.
Sir, 4.9 to
4.8.
5.1.
Just a minute. Yeah, tell me.
4.9 to 5.1, sir.
No. Give me the dimension in tolerance plus like plus minus x plus minus something.
Sir, 5 plus or minus 0.1.
Okay. 5 plus minus
0.1.
0.1. Everyone agree or not?
How it come?
Sorry.
I don't understand the logic.
Nitesh, could you please explain?
Yes, sir. Whole dia is there no? Who asked?
Sachin
Sachin.
is there.
Whole dia is 5 plus or minus 0.2. So take that maximum value and minimum value. The cylinder should be in between that hole tolerance, so it will easily fix in that hole, or it will more if you give more tolerance to that hole diaph hole. This is the concept.
Okay. Understood.
I think you got it. Okay.
See, Sachin, everyone, see. What is the diameter of hole? Hole diameter is 5 plus minus 0.2. Means the maximum size of the hole can be 5.2. Yes, Sachin.
Yes, sir.
And the minimum dimension of the hole can be 4.8.
2.8.
Okay. Now, again, same. Max 5.2, min 4.8. Same for cylinder. Tell me the max and min. Max
Maximum is
5.1
5.1
and
and
min
minimum is 4.9.
4.9. Now tell me, is this okay or not okay?
Not okay, sir.
Why?
Why? Uh, Sir, if we manufacture hole of 4.8, then minimum dimension of cylinder 4.9 not able to pass through that hole. That means we have to manufacture cylinder less than 4.8. That assembly is not possible in that case. That's why it is not okay.
Okay. Here you can see what is the minimum, what can be the minimum dimension of the hole? Pranali?
4.8.
4.8. What can be the minimum diameter of the cylinder?
4.9.
So suppose the hole diameter is 4.8 and the cylinder diameter will be 4.9. So is it good for you for assembly? Is it good? Can you pass the cylinder through the hole?
No, sir.
Sachin?
No, sir. No.
No. Again, for max, diameter of the hole is 5.2. Maximum diameter of the cylinder is 5.1. Is it okay?
Yes, sir.
Okay. So for the maximum, the dimension is okay. For the minimum is not okay. Suppose in manufacturing, so what is the use of tolerance? What we are, if we are providing this tolerance, what is the meaning of this tolerance? Suppose the white is your sheet metal plate and there is a hole and the whole diameter is 5. You are, and it is means there can be some error, some machining error or position error. Yes or no? There
Yes,
can
sir.
be some error. It will you if you are mentioning the 5 diameter, every time it will differ. It will differ. Yes, the dimension will differ. It will be something 5.05. It can be 49, 4.99. Yes. So we are giving this tolerance just to accept the design of the cylinder. And what is this tolerance? So the meaning of tolerance is, okay, sir, if you're providing cylinder, if you are having any vendor for this cylinder and you are collecting this part from that vendor, so you will accept this part if your cylinder diameter will lie between these two dimension. Okay, got it?
Yes, sir.
Same for the cylinder and same for the sheet metal. If there is a second vendor for the sheet metal and they are providing this part to you, so you will accept this part if your cylinder diameter in between this dimension. Getting? Yes or no? Yes, Sachin, Nidesh?
Yes, sir.
Yes, sir.
Okay. Now here you can see for max is it okay? It is okay. But for minimum it is not okay. because the minimum diameter of the hole is 4.9 and the minimum diameter of the what this is cylinder. Sorry, this is hole. Minimum diameter of hole is 4.9 and the cylinder diameter minimum is 4.9 and this is 4.8. So it is not going to work because the hole diameter is smaller than the cylinder. So this dimension should be less than 4.8. Yes or no? So if I, what should be the minimum? Tell me now. What should be the minimum dimension for the cylinder? It should be smaller than 4.8. Yes or no?
Yes.
Yes, sir.
Should be less than 4.8 mm. So what will the tolerance for the this is for cylinder? What should be the tolerance? Suppose this is 5. So tolerance will be plus 0.1 and minus
0.3.
0.3 or 2. Let's take step side 3. Yes.
Yes, sir.
Now tell me what is the maximum dimension for the cylinder? 5 point
1.
and minimum dimension.
4.7.
Now tell me, is it okay for hole? Is it okay for assembly?
Yes, sir.
Got it everyone? Pranali, Nitesh?
Yes, sir.
So this
Yes,
is a
sir.
calculation for the assembly. And what is the, now tell me why you have changed the tolerance? Because anyhow the dimension of the cylinder is going to vary. It will not be same perfectly 5 mm diameter. So just you have taken, you have given some tolerance to the vendor. Okay. Okay. Suppose Nitesh is supplying me these cylinders and Sachin is giving me the sheet metal. So I will collect the sheet metal and I will measure the diameter of the hole. If the hole is in between 5 plus minus zero point 0.2, then only I will accept this part from Sachin. Otherwise I will reject. Okay. And suppose Nitesh is providing me the cylinder and the diameter of that cylinder should be in between this one, then only I will accept this cylinder from Nitesh. Otherwise I will reject. Why? Because if I accept this cylinder, it will not going to work for my assembly. Yes or no? Yes.
Yes, sir.
Yes.
Nitesh, Sachin, everyone.
Yes, sir.
Okay. So this is a calculation of dimension. Now what is stack up? Stack up means here you have mentioned 24.4 max between this black line for the red part and 23.6 minimum between this black line. Now, tell me about this one. Okay, just a minute. Now, what is the difference between these two? Max and min. What is the difference between max and min?
2.
0.8.
Tell me the this
0.8.
0.8,
1 mm, sir.
1 mm.
Yes, sir.
Ah,
Okay, 1 mm. So what is the meaning of 1 mm means? Let me calculate. See, 1 will carry this will be the 4. See what is the difference? 0.8 mm.
0.8. Yes.
0.8 mm. Yes.
Yes, sir.
See, we called it as tolerance stackup. Okay, don't do some small mistakes. Everyone getting the difference between max and min? 0.8. Nitesh?
Yes, sir. Yes, sir. Now got it,
So
sir.
what is the point? What is the meaning of 0.8? 0.8 means you have given freedom of 0.8 means your axis of the locator can vary from here, from here, from here, like this. Yes or no? Between this zone, your axis can vary. Means the position. You know this point, yes or no? The origin of the locator. It can vary in y direction between this dimension, 0.8 mm. Are you getting?
Yes.
See, this point can be here, this point can be here, it can be here or here. So the range will be 0.8 from this one. So if you calculate from this point till this one and this point till this one, so the difference will be only 0.8. If okay, again the same condition. Suppose for the red part, Sachin is supplier. For the yellow part, Pranal is the supplier. So Sachin will provide me this red part. How I will check the part is okay or not okay? I will check the distance between this locator and this locator. The distance between the axis or this point and this point. So it should be between this dimension. Then only I will accept this part. Now same for the yellow part. Now the vendor is Pranali. Okay, now tell me this is the mean and this is the max. This is a okay, this is max.
0.6.
What is the difference?
0.6.
The difference is 1 carry 6.6. Now here you can see the distance from this line till this line, again from this line till this line. It can vary. The position of this window will vary in distance of 0.6. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. This will vary between 0.6. Let me note it down 0.6 mm. Okay. Now, are you sure that this red part with this locator and the yellow part with the window, these are going to assemble perfectly? Okay. See, for the red part, Sachin is the vendor, and for yellow part, Pranal is vendor for me, for my company. Okay. Now, Sachin is providing me this 1000 quantity. For the red part, let's consider 1000 quantity. And for yellow, Pranali will provide me same 1000 quantity. Now I want to make pair of this. So I want to make 1000 pair. Tell me, will it work or not? Red part will assemble in red color. Red or red will assemble with yellow part. See, we have this much tolerance. Focus on this. This tolerance and this tolerance. Focus on it. Will it work?
No, sir.
Why?
Um, the difference of yellow part is small, sir. On the red part.
Yeah. If I zoom this locator, if I redraw the locator will be something like this. Yes or no? This condition, okay? I just redraw. Okay, the worst condition will be 0.6 and 0.8. suppose this is the pointed condition. Now this is the axis, and here's the point of the locator. Now for the yellow part, the window can be here, yes or no? Tell me yes or no. Because what is the distance? What is the difference between this and this tolerance?
0.2.
0.02.
0.2, not 0.02, Sachin. 0.2, yes.
Yes, sir.
Yes,
So
sir.
so this can be the error. Are you getting? This can be the error. Tell me, can you assemble your this locator? See, as I mentioned, this will be your master locator. This is your master to position the red part within yellow part. First, you will assemble this locator. Then you will try to assemble this one simultaneously. So there will be condition that this will be the overlap of 0.2. Yes or no?
Yes, sir.
So Pranali, whatever we are doing, the plus minus of all tolerance in one direction, the plus minus of second part tolerance in same direction, we call it as stack up. Okay, we are summing up all tolerance with total dimension. Then we will calculate whether your part is okay for assembly or not. Got it?
Yes, sir.
Raja, Nitesh, everyone.
Yes, sir.
Now tell me why we are providing entry chamfer. Suppose if I provide entry chamfer like this and assume that your window is something here now on the entry chamfer. Now is it okay? Can you push little bit your red part downward? Because of entry chamfer it will align automatically. You will need to apply a little bit. You means you will need to apply force.
Yes, sir.
Okay. So this we called it as tolerance stack up. In doubt?
Sir, always stack up calculated in one direction.
Yes, because most of the time we will have to do see the calculation will be in x, in y, in z. In all direction you have to do stack up. Okay. Now tell me, I think we have done this example. Tell me. Okay, let me take the screenshot. We have time, yes? How much time we have now? Okay, we have 15 minutes again. Pranali, clear? In doubt?
No, sir, no doubt.
Okay, we should cover this topic in advanced batch, not here, but it's okay. Okay, again, one question. Sir, how to decide what should be the tolerance value? Yes, Pranali, this can be the next question.
Yes, sir.
So it should be 0.1 or 0.2 or 0.3 or 0.5. Tell me, suppose that is, suppose this is Sachin. Okay, and here is one pole. This one. and there is another pole in with the red color, this one. Okay, and Sachin just wants to hit this stone on this pole. He's throwing this stone on this pole. Tell me to which pole he can hit easily.
Bigger one.
Red.
Okay, now the now tell me, avoid the red one. Okay, just avoid the red one. Tell me to which pole he can hit easily.
White.
White, not yellow. Okay. Mm, now
Yellow.
why?
Bigger. White.
It's wide. Yes, wider than the white one. But what about the distance? What about the distance? Yes, Sachin. Pranali, Nitesh. So where is the more accuracy? Okay, let's keep this uniform with same dimension. Where is the more accuracy?
White ones.
Yes. Why?
So lesser distance and
Okay. So where will be the maximum chances for the rejection? Means failure. Where will the maximum chances of failure? Means you will reject Sachin. Suppose Sachin is not able to hit out of 5, if he failed to hit 4 stone, we will reject. Tell me in which case we will get maximum possibility for the rejection. Yellow or white?
Yellow one.
Yellow.
Yellow. Means from this to this distance, you have maximum chances for the rejection as compared to this one. Yes.
Yes, sir.
But if we increase the tolerance of the pole, can we save Sachin from the rejection? Now, can we save Sachin if we increase the tolerance?
Yes, sir.
Now you got what should be dimension. Suppose this is the dimension, let's say 100 plus minus 0.5. This is 200 plus minus. What should be the tolerance? Nearly. What should be the tolerance? Quickly.
0.8 something.
Nitesh, Sachin.
More than 0.05.
Let's consider one because we have double the dimension. The distance is double 200. Instead of 100, it is 200 now. So let's double the tolerance. Means now we have equal possibilities. Yes or no? In both case. Yes? Yes or no? Suppose the diameter of this pole is 10 mm. So this will be 20 mm. Yeah. Now we have same possibilities, same chances. Means we have just covered the chances of failure in this for this condition. 20 mm pole. So what we had done, we had just increased the tolerance for this area. Why? Because the distance is more. So accordingly, suppose if there is a part, let's take a rough part like this: 1, 2, 3, 4, 5, 6, 7, 8, something like this. And there is a dimension over here: 1, 2, 3, 4, and 5. You have this dimension. This is your master, this hole. Now you are giving dimension from that circle. So this will be your first dimension. Tell me, will you apply dimension like this? Yes or no? Will you apply dimension like this? Yes. Akash, Raja, will you apply this
Sir, we
dimension
can apply, but
like this?
tolerance
No, sir.
What will happen if you apply some like this?
Bulging,
rejections.
bulging or uh, failure of assembly.
Why there will be failure?
Sir, hole will be okay, sir, but hole will be if the first hole will displaced, the total will get collapsed.
Awesome. Are you getting Pranali, Sachin?
Yes,
Yes,
sir.
Rahul, Sach, Raja.
Yes, sir.
So every time dimension should be something like this: first, second, and third. Okay. Now, suppose this is a dimension from this hole to this hole. This dimension value is, let's say, 25 plus minus 0.2. Tell me dimension for this one from this hole. Okay, this is a position. Okay, this is the axis of the hole. Tell me this dimension from this till this one. This is 120. What should be the tolerance? It should be 0.2
Yes, sir.
or should be more than 0.2.
We need extra tolerance
Why?
because chances of failure.
Okay. Okay. See the same example as above. If we are increasing the distance, we will need little bit more tolerance because there will be some error from this point till this point. So let's take point 5 or 6 for now. So as we increase the distance, the tolerance value also increase. Okay, sir, but I don't want to mention this dimension. The 0.6 tolerance is too much. So you will need one datum. What we call it as? We call it as datum. Suppose this point is your master, this hole. So this will be your datum. Means this is master. From this datum, you will measure all dimensions. So suppose if you don't want to give zero point 0.6 dimension, you want to apply 0.2, try to minimize this dimension. How you will minimize? If suppose this face is your datum, consider this face is your datum, this one. Then the features which are near to this datum, I will take dimension from this one, this datum. If this is my datum A and this is my second datum, so the features which are close to my second datum, I will take dimension from this point. Are you getting yes or no?
Yes, sir.
Why? Because from this side, if we measure, dimension is small and I can control it very easily. So for this one, we will discuss about 3 to 1 principle. Yeah, we will cover this topic in 3 to 1 principle. Everyone knows degree of freedom, yes or no? What is degree of freedom?
Yes, sir.
What is degree of freedom?
Sir, degree of freedom is the movement around the axis of any part.
Okay,
Means free movement at uh, uh, at at 6 angles, sir.
okay. What is 6 angle means? Which are the 6 angle?
Sir,
The
x
Three
axis.
translation and three rotation.
Sorry.
Three translation in XYZ and
Hmm.
three rotation
Awesome.
along XYZ.
Good. So how to lock 3 translation and 3 rotational? The concept of locking this what we can say motions, we call it as 3 to 1 principle. So to any part, to any object, how can we lock? So we will need to lock 3 translational, 3 rotational. If you lock this 6 motions, you will able to lock that part in a particular position. Okay, so we call it as 3 to 1 principle. So with the help of that principle, okay, so what is datum? You mentioned datum. With the help of 3 to 1 principle, we will finalize, okay, this will be my datum. This face will be my datum. And again, I will need one datum along Z. So let's say this face will be my datum. So what I'm doing, I log this motion. I log this motion. Also with the help of hole, I lock up and down and left to right motion. What is open? The open, yes, with the help of axis also, I have closed the motion. Because if it is a axis and if there is some thickness for the part, tell me, if I put one axis over here, can you rotate this green part in this direction? Yes or no? Can you rotate?
No, sir.
No. So means I have locked this dimension, the rotation. We will discuss this in detail, okay? So the concept is clear, yes? Pranali, what is tolerance stack up?
Yes.
Good. Any doubt? Any doubt?
No, sir.
No.
sir.
Okay. Then shall we stop and shall we move to next session? Advanced session? Yes?
Yes, sir.
Okay.
Yes,
Thank
sir.
you.